Okay, so in this thing, I want to walk you through this kinematics and vectors problem because it's actually a good one and it caught me quite off guard because of the context, but then I eventually figured it out. So first, you really need to read the question carefully because you might miss something. So here in the question, we see there's a setup that there's a commercial airliner and a flock of migrating birds. So both are given as vector equations in 3D. So the x coordinate is distance east, the y is distance north, and z is the altitude, and all of these are in kilometers. And t is the time in minutes past 10 a.m. So you need to get this information and make sure you understand it before you start doing the math to make sure you're not doing anything wrong. So once we have that, part A is like finding the speed of the migrating birds, which is pretty straightforward. All you do is, with that, you can find the velocity vector here, which is negative 0.40, negative 0.35, 0.1, and all you need to do to find the speed is to find the magnitude of this. So it's just negative 0.40 squared plus negative 0.35 squared plus 0.1 squared, and then that should give you around 0.541 kilometers per minute. So that's part A, simple. Now part B. Part B asks you to provide two distinct descriptions regarding the flight path of the commercial airliner based on its vector equation. So this part tripped me up a bit because I wasn't reading the vector equation carefully enough. So the airliner's direction vector is negative 1.4, 1.65, and 0. So once I have that, the first thing that stands out is the z component, which is 0, this one right here. So meaning altitude never changes. So the airliner is flying at a constant altitude of 7 kilometers the entire time. That's the first thing you need to point out and really understand in context. The second one I missed initially was I just said it's moving, which is too vague. So you need to do is look at the signs of the x and y components. So x is negative, you see here, meaning it's moving west, and y is positive, meaning it's moving north. So the airliner is flying in a northwest direction. That's the second valid description. So the first one, as we said, the first description would be that the plane is flying in a straight line in a northwest direction. And then the second one, it is flying at a constant altitude of 7 km. Okay, so you see, you really need to understand, and you have to read the problem carefully and really understand the context behind it, so you can get these type of questions correct, which is what I usually have difficulty with. Now part C, there's something interesting because it asks whether they will actually collide, and so this is where it gets interesting because they're at the same altitude. Doesn't mean just because they're at the same altitude doesn't mean they're going to collide. You need to check whether they're at the same x and y position at the same moment. So what I did was I substituted t equals 10 into both equations. So the airliner for C1, the airliner is 5, negative 2, and 7 plus 10, negative 1.4, 1.65, 0, and then this would equal negative 9, 14.5, and 7. So that's how I did. I substituted 10 to get that. And then for the birds, I did negative 11, 36, and then plug in the 10, negative 0.40, negative 0.35, and 0.1, and that would equal negative 15, 26.5, and 7. So both are at an altitude of 7, which is confirmed, but the x coordinates are negative 9 and negative 15, and the y coordinates are 14.5 and 26.5. Because those are completely different, they have different horizontal positions, so they are not at the same space point in space at t equals 10, and so that means there's no collision. And so basically the mistake I made here was stopping at part 1 and assuming the same altitude meant collision, which is something that, because I didn't really understand the context, I got that part wrong. That's why you need to really look deep into that, because the hard questions usually the hard questions usually trip you up on that type of stuff. So you need to make sure you really understand the context with these type of questions. So yeah, thank you.